Howdy, this is Tyler Disney. I'm going to be walking through how to create and edit and modify mechanical equipment families. If you've got the RevX warehouse, mechanical warehouse and template, this is essentially required skill to use that stuff. You really need to understand the content of this tutorial in order to be able to fully utilize the assets in there. That being said, if you don't have the RevX stuff, this is still a useful tutorial, a video. You can follow along. You don't need anything at home. There's one or two things. I've got a shared parameter file, my own shared parameter file. And if you don't have that, you could use your own. You could create your own. And also you could kind of skip that. So what we're going to do is we're going to make the most basic family, and then we're going to build and add complexity from there. So I'm just going to get to it. So I'm working in Revit 2023. The family editor hasn't changed much over the years. So probably whatever version of Revit you're in is fine. So go File, New, Family, go to your correct library. We're going to go Mechanical Equipment, not ceiling or wall based, just mechanical equipment. And here we are. We're in the Family Editor now. First thing to do is to save. And so I'm going to save this to my desktop. I've got a tutorial thing here. We're going to call this M Family Tut Magic Box. So the first thing to understand is that when making geometry, you really start with reference planes, and then you attach geometry to the reference planes. So create a reference planes. Use RP is the keyboard shortcut. If your version of Revit actually loaded the keyboard shortcuts, reference plane, add RP sign. A little bonus tip for you. If you want to remap keyboard shortcuts, type in KS, and then you can add that here. So reference plane is also up here. But anyways, reference plane, and I'm going to draw a rough box like this. Don't have to be precise because we're going to define things using math. So then I go into the align dimension tool, DI. It's also somewhere up there. All right, I'll show you. It's annotate, right? And then aligned. That's where it is. Okay, so then click the leftmost reference plane, click the rightmost reference plane, then click the center reference plane, then click off to the side. And you notice it says EQ. It's got a slash through it. Click that. So what that has done is that has forced these reference planes to be symmetric about the center line. Okay, do the same thing for the top and bottom. So DI, top, bottom, middle, click, EQ. Okay, now we want to actually give parameters to this. So I'm going to go DI again. That's annotate, align dimension, left parameter, right parameter, planes rather, pull it up, and then top plane, bottom plane, pull it down. I'm going to select this dimension, and up here where it says modify dimensions, label, none, I'm going to click this button, which is create parameter button, and I'm going to give it, I'm going to call it equipment length. And I want this to be a type-based family, so I'm going to keep this as a type-based parameter. Over here, I'm going to call this one the equipment width, type-based, okay. And then I'm going to come into the front elevation, and I'm going to make a reference plane, RP, just draw it there, do DI for align dimension, and then I'm going to reference down here. Now there's two things here. It's kind of hard to see, but there's a reference level and there's a reference plane. So if you look down here in the lower left of Revit, if I mouse over, it's saying levels, level, ref, level, reference. And if I hit tab once, you can see I'm now selecting a different dashed line, and that says reference planes, reference plane, reference. Very helpful. Anyways, you want it'd be I won't go into it in too much detail, but pick reference plane. So tab, select the one that says reference plane, not the reference level. Click that once, click the reference plane you just made above, and click off to the side, select that, and we're going to call that equipment height, that dimension. Okay. Another thing that you can do, so if you want to build extrusions off of any plane other than the reference level, they need to be named, otherwise they won't show up. That might not make a whole lot of sense right now. Just note that. So I'm going to call this one, this reference plane, I'm going to name the reference plane top of equipment. Okay. And I could come up here in reference level and call this like left, right, back, front. It's not necessary unless you need to build geometry off of that. That's just a note for later. Okay. So now we've got we've got our reference planes, but if we go into the 3D view, you will see nothing because there's nothing. You can't see reference planes. We don't have any actual geometry yet. So let's make some geometry. Let's make our first geometry. Go to the Create tab, click Extrusion, choose the rectangle object, and mouse over so that you're getting the intersection of these two lines and the intersection of those two lines there, those two reference planes, and click once, and then you can see that there's these unlocks padlocks. You want to lock them. Because remember, the dimensions that we've created, equipment length, equipment width, etc., they're driving the reference planes. They're not driving the geometry. What we're doing is we're locking the geometry to the reference planes, which are being controlled by the parameters. It's good to keep in mind what we're actually doing here. Okay, and then over in the properties window where it says extrusion end, so you could type in something manually, or you could set that to the equipment height. Okay, and then hit the green check button. And now if you go to the 3D view, you can see that we've got a lovely box. Okay, so now what we can do is go into the family types button. That's that right there. And we can set the parameters for this. So let's say we want a 2-foot cube. 2 foot. It's going to be a 2-foot cube. Hit OK. And we can see that it is now 2 foot. And there's an activity called flexing, which is when you've created new parameters, you want to quote unquote flex them to make sure that your stuff is working. So I'm going to change the length here to 6 foot, hit apply. It did what I expected to do. I'm changing the width to 3 foot, or the height rather to 3 foot, and it changed. And I'm going to change the width to 1 foot. Yep. So now I've successfully flexed it. I'm feeling good about that. And I would like to make another type of this. So up here where it says type name, it's all blanked out. I'm going to say make new type. I'm going to call it type A. And I'm going to make another type, and I'm going to call that type B. And type B is going to be a 2-foot cube. And if I move it back to type A, it's that. I'm going to make this just a 6-foot cube. Okay. So if I'm in, this is, what did I say? Type A is the 6-foot cube. Type B is the 2-foot cube. Okay. And then to test it, I could either pull up a project or anything else I've got. I can also just file, new project, use whatever template pops up. So now I've got this, and I go from my family. I can load into project and just dump it in there. See what it looks like. I'm going to go into families, mechanical equipment in the project browser. And I can see my family, m-family magic box, and type A and type B. So if I click and drag, that's a type A, and I click and drag, that's a type B. And from here, of course, I'm sure you're already familiar with this, I can go into edit type, and I can see these parameters. Okay, so now I've got my family loaded into this project kind of as a sandbox to test it. And I've also got my family editor open. Now, observe what I'm about to do here. So I'm in the family editor. If I go to family types and I change, let's go to type A. Type A, that's my 6-foot box. I'm going to make this, I'm going to make the height 1 foot. So it's more like a 6-foot puck, kind of, okay? That's what it looks like. That's type A, and type B is the 2 foot cube. Type B is the 2 foot cube, right? Okay, type A. Okay, so now I'm going to say load into project, and I've got an option here. It says overwrite the existing version or overwrite the existing version and its parameter values. Well, what exactly does that mean? Well, let's find out by experiment. If I hit overwrite the existing version and I go into a 3D view, where's the 3D view? Here. Type A is still a 6 foot cube. It's not a 6 foot puck. Why is that? That's because we chose not to overwrite the parameter values, the values of those dimensions that we created. Now let's go back into our family editor. It's still the 6 foot puck here. Let's say load into project. Well, it's we need to make a change because it remembers what we did. So let's make that equipment height even less. It's 1/2 foot, 6 inches, a little disc. Okay, now load into project. Now I'm going to say overwrite the existing version and its parameter values. And go into that 3D, and now it's a puck. So one versus the other, you should understand what you're doing when Revit asks you if you want to override the parameter values or not, because you can destroy information. Let's say that you load a family into your project, and then you add a bunch of schedule data to that family, to the shared parameters in that family, and then you open up that family from an external source. So you're in the family editor, but you didn't open it from the project. You opened it from wherever it lives on your desktop or your computer or your server. And that version of the family won't have that new schedule data. And if you load that into your project, let's say you make a change to the geometry, and you do select override parameters, it will delete, overwrite with nothing, the data that you had entered. So it's important that you understand what you're doing. One thing that I do like to do, if I'm going back and forth in between a family and a project, testing it, making sure it works in the project environment, is I will use the load into project and close button. So that means that I'm either in the family editor or I'm in the project, but I don't have it open in both at the same time. So I would do load into project and close. I would just say, no, I don't want to save it. So now I'm in the project environment. I could make changes. Okay, type B, that's going to be actually 3 foot wide, whatever. And now if I want to make edits, I go edit family, and type B is 3 foot wide. So that is changed. And if I make more edits in here, then when I'm ready to test it, I say load into project and close, no. And likely I'm often overwriting this existing version and its parameter values, but that's safe because I haven't decoupled the family in the editor versus the project. Okay, so that's just a workflow that I do to keep myself out of trouble. Okay, that's kind of a deep dive on not getting yourself in trouble with families and when you're editing. It's important to keep in mind. Let's add a little bit more complexity and usefulness to this family. So let's add a clearance zone. Let's say we would like to have a clearance zone coming off of the front of this family. So I'm going to go into Edit Family, and I'm going to go into the reference level. And I want like dashed lines that come out here to represent the clearance zone. I'm not a fan of using 3D objects for clearance zones. I'm a fan of using just lines. Okay. So first of all, we need another reference plane. So RP. I'm going to call that. I'm just going to put it there, and then I'm going to say DI for a line dimension, and I'm going to click. It matters which of these you click first, by the way. So I want this parameter to be a certain amount of distance from this, not the other way around. Yes, there is a difference. So I'm going to click this parameter first, the front of the unit, and then I'm going to click my clearance zone plane and move it over here. And I'm going to select it, and I'm going to come up here, say create parameter, and I'm going to call this clearance front. I would like that to be a type parameter, so that's okay. I'm going to come up here into family types and clearance front. Let's just say I know I want that to be 18 inches for both types. 18 inches. And I'm going to make this less of a puck. I'll make that cube again. Oops, 6 foot. Okay, so it's my clearance zone is 18 inches for both of these families. Okay, so now I want a line here to represent the clearance zone, but I want the line to be dashed. So create, I'm not going to create an extrusion, I'm going to create a model line for this. And then over here in subcategory, I have hidden lines and I have invisible lines. Those are out of the box Revit defaults. I don't really want to use those. I want to use a line that kind of lets me know what it actually means. And invisible, by the way, you can't see it. So what to do? Well, I go to the Manage tab, Object Styles, and then I create a new subcategory. And I'm going to call this Clearance Zones. Now, the naming of this matters. When you push this family into your project, it is going to add this subcategory to the subcategory of the project. That way you can control it using visibility graphics. So that's actually a really great feature. But you wanna make sure that you're naming it consistently, because let's say you call this clearance zones. Let's say you make another family and you call it clearance zone with no S. You make another one and you don't capitalize the Z. Now you've got 3 different clearance zone /S's in your project, and that's how you get really junky projects and templates and that sort of thing. So pick a naming convention and stick with it. The RevX standard is clearance zones for the generic ones, and there's also clearance zones dash rooftop equipment, etc. But we try to keep it consistent. And then you don't really have to, but you can change the color and the line pattern. The reason I say you don't really have to is because this will be overridden by the object styles in the project, and that's what will actually wind up on your drawings. Okay, but we've created this, clearance zones, good. And we come back here to create model line, modify here. Let me just start over there. So to recap, I went manage, object styles. I created this subcategory. Now I'm going to go create model line. And for subcategory, I'm gonna select clearance zones. Now I want these lines placed on these reference planes. There's more than one way to do it, and I'm gonna show the really safe way to do it. It's gonna be a little funky though. So what I'm gonna do is I'm gonna draw a U, like an actual U, here, not where I want it. And then I'm going to use the align tool, AA, AL, or just modify align. It's up here. There it is. To get this locked to these reference planes. Sometimes if you draw it on top of it, it can be messy. If you have a complicated family that's got a bunch of geometry, it can be difficult to snap it to where you want. So I do this so that I'm being certain I know what I'm getting. So I'm going to, with the align tool activated, select that reference plane, and I'm going to mouse over so I'm getting the end of that line, and I'm going to lock it. I'm going to do the same for that one. Lock it. I want that locked there. Lock it. Align. Lock it. Align. Lock it. Okay, let's go into the 3D view for that. So there's my clearance zone. That is how I want it to look. I'm happy with that. Let's flex it, change it to type A, make sure that it looks the way it's supposed to. Yep, looks good. It moved with the reference planes. Let's flex it by changing the length. Okay, that looks right. 1 foot. Okay, that looks right. Let's just see out there, 4 foot. Okay, and then I'm going to see how it looks in my project. I'm going to load into project and close, because that is my sort of default to keep myself out of trouble. I'll override its parameter values. So that looks good, and I will demonstrate. So if we go into VG and we go to mechanical equipment, you can now see this clearance zone category. And I can turn it off. I can turn it on. I can override the color. I can make it, green instead. So I've got a lot of control. Ooh, don't like that color. But that now exists in my project because it exists in this family. And I could now delete this family and that subcategory would still exist in the project. Okay, so that's good. But what if I wanted to turn the clearance zone on this box off and not this box? Because if I use VG to turn it off, it's going to turn them both off. It's going to turn them all off. Well, let's use a visibility control parameter. So let's go edit the family. And I am going to tab select all this. So just mouse over till it highlights, hit tab, then left click. So I've got that selected. Over in the properties window, it just says visible and there's a check mark. So I could turn that off so you can't see it. But that's not actually what I want. I want to click this little button to the right of the checkbox. That's the make a parameter to control this variable button. So I'm going to hit the new parameter and I'm going to call it clearance front. I'm just going to call it clearance front. And this one, I don't want it to be a type parameter. I want it to be an instance parameter. So I'm going to hit instance. I'm going to group the parameter under visibility because that seems to make sense. Oh, that's right. Clearance front, because clearance front, the dimension is named clearance front. So right on Revit, clearance front visibility, let's call it. Okay, hit OK. And now to test this, I'm going to load it into the project and close. I'm not going to save it, and I am going to override. And now if I click this one here, I'm going to do that, and that pops off. So I'm going to create it. So I just select this. I'm going to create similar, CS, create another unit. So these are both type B, and I can have this one with its clearance zone on and this one with it off. That is the power of instance parameters. Okay, now let's say that I want to add some of my standard shared parameters to this family. There's a few different ways to do that. So the standard way, if you don't have a plugin to do it, let me think. I always use a plugin, which we're going to talk about in a second. You would have to go. Okay, you'd have to edit the family. Where is that? Manage, view, edit family. There we go. You would go to family types. You would go to add parameter. You would say shared parameter. You would say select. You would choose a file. You would go find your shared parameters file, which I just threw on my desktop. There. And you would start adding your parameters. Not that common. Click by D. That one's an instance. Okay, cool. I've got it. Boy, that was labor intensive, and I've got like 50 to go because this is a chiller or something, right? So forget that. Don't do that. Get a good plugin. I use DiRoots. I use DiRoots Run. It's great. Makes my life easy. They just went to a free/premium model, but the free version has what I'm about to show you. So you should just have that. There's other plugins that do something similar to what I say, but we've standardized on DiRoots 1, so that's what I'll be showing in my tutorials. Right, so we're in the family editor, right? Yep. And we can add parameters here. So let's go DiRoots 1. We go to paramanager. And so it's now listing all of the parameters in my family. I'm going to say only don't show me built-in or family parameters. I just want to see shared parameters. There's none because I haven't added any. So to add some, don't hit add. That's like create a new parameter. You don't want to do that. You want to pull in shared parameters from your shared parameter file. So import export, import shared parameters. And again, we've got to point at the correct file, shared parameter file. And so I know what I'm looking for. I just want my common parameters, the standard ones. So I always want that. This isn't going to mean a whole lot to you if you don't have the RevX shared parameters, so I'm not going to bother you with it. But you get the sense, right? Like there's a naming convention for all of our shared parameters. Model manufacturer. Some of these are specific to certain kinds of equipment, but almost every bit of equipment is going to have model manufacturer. Equipment ID, that's what our tags do. You know, this is a square thing, so I don't need the diameter, but the length and width, if you want to report that on a schedule, that's nice. Yeah, so let's hit location. I want location as well. So I'm going to import those. And then I've got some choices here, like where I want to put them. And I'm going to say I actually want all these to go under, gosh, I think it's others where I typically stick these. And then some of these I want to be instance and some of these I want to be type. So it actually doesn't matter. Notes, I want to be instance. Description, I also want to be instance. Unit type, it's got type in the name, might as well be type. Weight, that's type. Service, that could be instance. Equip ID wants to be instance. Model and manufacturer want to be type. Both want to be type. And then I can make that type because my dimensions are types. Okay, so that's good. If I wanted to assign some default values, I could do that here. I'm just gonna slap them in there. Say apply. Completed. Okay. And if I go to family types, here they all are. Now you notice that the scom width, length, height, these are 0 by default. And you'll also notice I've got dimensions for equipment height, length, width. This is what actually controls, my geometry. But I can't schedule this information. If I want to schedule this information, I need to tie these somehow to these shared parameters. Well, that's easy enough. So I can set the scom width to equal equipment width. This has to be exactly correct, case sensitive and all that. So you see scom width is now the value is 6 because it's linking to that. So equipment length, equipment height. Okay, I'm going to load it into the project. Don't want to save, and I do want to override. So now if I select this, you can see here's my instance shared parameters down here. And here are my type shared parameters here. All schedulable. Okay, so that's all great. And you can do a lot with just a box. Almost everything is just a box. Even tanks are basically boxes with a little margin of error. And honestly, like, if you don't have more sophisticated families on hand, you can do most of your design with just a bunch of magic boxes. Magic box AHU, magic box RTU, and you can just know where the duct connections come in and out, and you can bring them up there. And unless you're on the hook for LOD 300 plus designs where everything needs to be within an inch, that's good enough for almost most drawings. This is like a dirty little secret. People don't know it. And it's fast. You don't have to fuss with things. I really encourage people, like, how simple can you be? The nice thing about boxes is they're they're rarely wrong, if that makes sense, for equipment. They might be not totally clear what it is, except you see the tag and it says CH, and you say, oh, that must be a chiller. And another one says RTU. Ah, that must be a rooftop unit. It doesn't have all the lines that shows it. Those lines are great. I'm not saying don't get more better equipment. I'm just saying make good decisions about and understand how detailed you really need all of your families to be. Like, do you really need the logo to be rendered in 3D on the outside of your box? Does it need to say train in literal embossed geometry on the side of your family? No, it does not. Unless you're doing shop drawings, and then of course it does, but we're not here. So anyways, what am I doing? Box. Oh yeah, fun stuff. So let's say now that we're like, all right, we've got our box. What we're trying to do here is we're trying to make this into something like a rooftop unit. Okay. let's say it's got duct connections on the bottom. All right, so let's open this family again. Let's edit this family and go into family types, and we're going to go type A. And let's see, I want to make this a little bit more RTU-ish. So the width is going to be 4 feet. The length is going to be 8 feet. The height is going to be like 4 feet. Clearance of the front, I think actually, yeah, 42 inches is probably about right. Type B is going to be a little bit bigger. Length, that's going to be a 10-footer. Width, 4 foot. Height, 5 foot. Clearance from 42 inches as well. Okay, so our boxes are, yeah, sure, fine. Okay, so what we want is basically what we've decided we need, duct connectors on the bottom here and about here. So return and supply. We don't really have to model the outside air intake, the economizer intake, because you don't connect a duct to that. You don't connect a duct to that. But we want our duct connectors for return air and supply air, right? So I could go down and I could start modeling more geometry, or I could be smart about it and I could use a nested family. So I'm going to open a family that I'll leave as a exercise for the reader on how to make. So this is an extrusion. This is a rectangular extrusion. So I'm going to open this. All this is this is a box that is built on it's a face hosted box. So to create this family, I did basically exactly what we just did, what I just showed you how to make the box, except when I went to go make a new family, I said new family, then I did generic face-based, generic model face-based, and then I made 4 reference planes and I made them symmetric and all that. And like you can see here, like here are the reference planes that I made, and it's called extrusion width, extrusion height, and then the height of this extrusion is locked to a parameter called extrusion thickness. Okay, and this is not something I made. This is just what exists in the family editor when you make face-based families. So you already know how to do this. I'm not going to go through and show you how to do this because you just know how to do it. Just do it with generic model face-based. And then when you get into it, come to this button, family, category, and parameters, and change it to mechanical equipment. And then once you've done that, again, very simple. The parameters, or the planes, 3 parameters, that's it. And then load into project and close and choose the magic box family, not the project. Okay, now look what's going on here. So this is face-based. So this family, the extrusion, wants to be stuck onto a face. So as I'm mousing over here, it's well, you can see what it's doing. So I'm going to stick it here. And you can see it kind of like stuck itself up that way. I want to point it the other direction, so I'm going to click this button, these arrows. I'm going to click that, so now it's pointing in that direction, which is what I wanted. And I want this to represent the return air duct connection. So I'm going to click it, and where it says extrusion height, this is the instance dimension of extrusion height. It says it's 4 feet. Now I think of height as this direction and width as this direction. So I'm going to say extrusion height. I'm going to click the button next to it, and I'm going to create a new parameter, and I'm going to call it return air connection. What did I say? Height? Yeah, height. Height. I'm going to make it a type parameter. I'm going to say okay. Okay. Extrusion thickness. I'm not actually going to assign this a parameter. I'm just going to leave it as 2 inches. I think that's fine. And extrusion width, I'm going to click. I'm going to say create a new parameter. I'm going to call that return air connection width. I want it to be a type parameter. I'm going to hit OK. I'm going to hit OK. Okay. So what did we just do? Well, come to the family types. Well, let's go with type A. Let's just hit apply. So we're working with this box here. You can see these are the parameters we just made. So return air connection height. Let's see if I've got this oriented the way I want. I'm going to type in 2 feet, and I'm going to hit apply. Okay, so that actually wasn't the direction I wanted it to be, so I'm going to rotate that in a second. RA connection width, I want that to be 3 foot. Okay, so I want it facing the other way, so I just select it and I hit spacebar. Okay, so that's where I want it. I'm just going to scoot it over here. I'm intentionally making it a little off-centered. So in this RTU unit, the duct connections are symmetric about this axis. Because right now this is just floating, and I don't really want a floating duct connection. So I'm going to come into the left view elevation, and I'm going to use my align tool, AA. I'm going to select the center line reference plane. I'm going to come in here, and I'm going to find the center line of this, and it was already on it. So I'm going to offset it so that you can see exactly what I'm doing. AA, center line, mouse over this until it shows me the center line of this extrusion family. I'm going to click it, and then I'm going to lock it. So now this duct connector is locked to the center line in this family. Okay, good. What about this dimension? Well, I'm going to create another dimension, DI, and I'm going to select the left reference plane, and then I'm going to select that edge of the extrusion. I'm going to pull it down, and I'm going to create a parameter called RACon distance from left side. I like to be really descriptive. Like, you could have just called this RACon dist left or something like that. It's, yeah, in a year you come back, you think you're going to know what that means. So I try to be really descriptive. It's less of a pain to have long descriptive parameter names, in my opinion. At any rate, I'm going to leave that there. I'm going to say OK. So I could come into my parameters. So here's my RA con distance from left. Let's say I look at my cut sheet. I see that that's 3.5 inches. I hit apply, and boom, there it is. Okay. And let's say I think to myself, you know what, that's 2 inches. That's a little too thick. Why don't it be 1 inch? Yeah, that's much more elegant. Okay. I'm going to come back into my 3D view, and I'm going to select this, and I'm going to say CS for create similar, and it's going to let me place this wherever I want. And in this case, I want to place it on the bottom, and it's defaulting to rotate it 90 degrees from what I want. So I'm just going to hit spacebar once to rotate it the way I want, and I'm going to stick it there. This is going to be my supplier duct connection. So you guessed it, I'm going to go into the left reference plane. You can see it's flipped, so I'm going to hit that button there. It flips it around the way I want it to be. Align tool, align to the center line, and that is the center line of that duct connection. I'm going to lock it, and then I'm going to come into the front, and I'm going to say DI. And it depends on what your cut sheet. Your cut sheet might give the dimension from this. It might give the definition from this end of the unit. I'm just going to say it's coming from the right end of the unit, since I'm not actually working from a cut sheet. And I'm going to name that, this is supplier con distance from right. Now, this isn't a completely descriptive. I'm not saying what is on the right, like the right what. I'm hoping I'll know what that means in the future. Make your own decisions about how you want that to be. Okay, so supplier con distance from right. Let's say I'm looking at my cut sheet, and that's actually 2 foot. Okay. Now, if we select that extrusion, we need to set its size. So extrusion height. Create SA con height. And SA con width. Okay. And again, I can go into my family types, SA con height. Let's say this one's a little smaller, so it's 18 inches height, and it's 2.5 foot wide, just so we can see that there's a difference. All right. And, that RA is looking not quite correct. RA con height. Let's say that that's actually 14 inches. Yeah. That fits my mental model of what an RTU looks like. Okay, so we've got that. Let's go check out our other type. What's going on with type B? Can apply. That doesn't look right. Those were our default values, right? So RA, let's say I'm looking at my cut sheet. This is the carrier, the other model that I'm trying to do. RA con distance from left, but that's also 3.5 inches. 3.5 inches because they tend to make those all standard. RA con height, yeah, I don't know, 18 inches, distance 5 feet. All right, con distance from right, 2 foot, con height, 18 inches, 3, width 4, sure, apply. Sure, good enough. All right, so we've got these extrusions that represent duct connectors, but of course, duct connectors, these technically are not. So let's put some duct connectors on them. Create, duct connector. I'm going to mouse over until this plane is highlighted, and I'm going to click once. And I'll do the same over here. So this is my return air. So I select that duct connector, and it automatically places itself in the center of whatever plane it's attached to, so I don't have to worry about its location, but I do have to worry about its size, its dimension. Luckily, I already have parameters for its heights and width, so I'm going to set those. So the height, this is the RA con height. Width is the RA con width. And then I have to decide what to do with all of this. So I'm going to do this, and then I'm going to show you how I knew how to do that. The flow configuration, my options are calculated, preset, and system. For this, I want calculated. I want that to be in flow direction. I want the system classification to be return air. That one's pretty obvious. The flow, I'm going to make a dimension called RA air flow, and that's going to be an instance parameter. And I'm going to call it RA con. That's connector description. All right, I'm going to repeat the same thing for the supplier. Give it the SA con height and SA con width. By the way, SA con width. My tutorial style is to go a little fast. Like, you probably can't follow this fast. There's a pause button. Just hit the space bar. Otherwise, it's like watching paint dry. So let's see. Flow configuration, calculated. That's what I want. Flow direction is out. Supplier's coming out. And then flow, SA, airflow, instance. Okay, and then SA con. Okay, so how did I know what to do that? In particular, the flow configuration, calculated preset system. What do those words even mean? Okay, so there's a classic PDF. Everyone knows about this. It is called the, it's from 2008 by, it's Eric Schmidt, I believe. This will tell us in a second. Martin, excuse me. I'm dyslexic with Eric and Martin. Martin Schmidt from 2008 AU. So you should read this. If you're making mechanical families or electrical or plumbing for that matter, you should understand this. So this is the gold right here, supply air distribution. So this is the D1 connector, T1, T2, U1. So this is like an RTU, this is like a VAV box, and this is obviously an air terminal. And then this table right here shows you what they should be. And then there's some discussion. And he also discusses pipe systems as well. I'm not going to get into this. I'm not going to talk through it. Martin Schmidt already did it way back in 2008. You can get this on the internet. Just go to, if you just type in, what is it? You can see I just did this. Getting into the flow, MEP connectors, Revit. It's the first hit. Just click that button. It's on the internet. Download it, read it, love it, etc. Right. I mean, let's just talk about this for a second, maybe. Like, look, the interesting thing here is that it's the flow of information kind of goes up. And so you want to tell the air terminals how much, what the CFM is, right? And then that flows through the duct. And the reason the duct knows how much CFM is there is because it's all being pushed in from the air terminals. And so those are set to preset. Then on your VAV box, this is calculated. Calculated means it's receiving the airflow information from the ductwork, which is receiving from it's adding up from all of the air terminals, okay? And then this connector is set to preset. So this is calculated, it's receiving information. This is set to preset. Preset to what? You set this equal to that, and then all of the VAV boxes are now pushing information into the ductwork system, that feeds into the RTU. So this is set to calculated. It's receiving the information from that side of the ductwork. It makes sense once you stare at this long enough. But anyways, there is more to connectors to understand that I'll get into later, but not in this particular video. Okay, so we made those, and then let's flex it. We always want to be flexing. Yeah, type A, apply. Looks good. Okay, so I say we test this. Let's load into the project and close. Let's override the parameter versions. And so we've cancel, and then we just had a couple on top of each other there. So we can see we've got our duct connectors. And I don't have any of the other like air terminals and stuff in this project to demonstrate that it works, but it does. So cool. Got those. Let's see, what else are we going to talk about? Load shared parameters, face-based extrusions, duct connectors, go with a flow. Yeah, I think that might be a pretty good place to stop. I'm going to just really quickly, so that extrusion family that I use for the duct connectors, you don't have to use them for duct connectors. I could also use this box to represent something like a weather hood on the intake if I wanted to, if I thought that was appropriate. I could use it to represent all sorts of stuff. And I could also, so I've got this, I've also got a round extrusion, same exact deal as what I made for the duct connectors, but it's round. So I'm going to push that into my project. That's rather big, but let's say I wanted to represent a drain connection. So I could say, let me just change that to like, what, an inch, half an inch? No, I'll just call it an inch. Yeah, so I could move this manually wherever I wanted. I could add parameters to say, you know, it's 3 feet from the left-hand side of the unit and it's 6 inches from the bottom, whatever. And I could drive these with parameters if I wanted to do that. And then I could create a pipe connector and stick it on there and give it a diameter that matches this. So actually, let me just go ahead and do that. So I've got the extrusion selected, extrusion diameter. So I'm going to give it a new parameter called drain con diameter. That'll be type parameter. Okay. And then for the pipe diameter, the pipe connector diameter, I'm going to set that to drain con diameter as well. So there it is. And then this would be, honestly, I'm not a plumber. I presume that would be preset because you just got like a flow that you might have. The flow's out. It's going to be sanitary. The flow is going to be drain flow instance maybe. And you can call this drain con. Okay. So you can use it for that as well. And you could also use that to represent coil connections and that sort of thing as well. Okay. So that was, how long was that? I don't know. I haven't been looking at the clock. So, but that right there, this video right here, this tutorial, this series of information, if you understand everything we just did, if you get to the point where you're like, oh yeah, I can do that without really having to reference the video or anything else, you can do most things. Like you've got the building blocks of understanding family creation, at least for mechanical equipment, that you can use to make a wide variety of things, edit things, create new types based on old equipment, that sort of thing. So I hope that you found something useful from this. If you have any questions, don't hesitate to ask. And there will be, I mean, the rabbit hole does go deeper, particularly when you get into specific types of equipment that you're attempting to represent. So there's going to be more series on more advanced topics. You could get into tags, annotation families, all sorts of things. At any rate, those are the basics. Those are what I consider the sort of requirement for entry into using and doing mechanical engineering family creation, and even really just using it in a project environment. These skills are very useful so that if things crop up with the equipment that you're using, you don't get stuck, that you can keep, you can solve novel problems. So I encourage you to master the skills, master the fundamental skills that we covered in this video, and you will be well on your way to being an elite BIM operator.